the TV turned off just when we were about to see the rocket launch. Now we're sitting here, with a heavy box, a tiny car, and a ball. So boring.
Newton's first law says it will stay resting until a force, a push, moves it.
Go on, Sorrow. Kick it. Big brother, whenever I or Mina jump forward, we push backwards on the floor.
Exactly. That's Newton's third. For every action, there's an equal and opposite reaction.
Hello, kids! I'm Captain AHS. Have you ever wondered why a ball rolls farther when you push it harder, or why we stay in our seats when a car suddenly stops? Today, we're going to explore the powerful laws of motion that explain all these movements around us.
TV turned off just when we were about to see the rocket launch. Now we're sitting here, with a heavy box, a tiny car, and a ball. So boring.
Boring? Guys, we have everything we need for a super action quest.
Super action quest?
Who wants to become motion heroes?
Motion heroes! Yes, we want!
Yes! Heroes who conquer obstacles using Newton's 3 wonderful laws of motion. Here's your first quest. Look at this ball resting on the floor.
It's not going anywhere.
Exactly. Newton's first law says it will stay resting until a force, a push, moves it.
Go on, Sorrow! Kick it! Whoa! It rolled across the floor!
See? An external force made it move.
I get it now. It's like when I put my book on the table. It stays there until I lift it. Or when we're sitting in a car and it suddenly starts moving, we jolt backwards because we were resting and we want to stay resting.
Exactly. That's inertia in action. Whatever is resting stays resting, and whatever is moving wants to keep moving, until something else interferes. Now we have 2 boxes here, small and heavy. Push them with the same force, and watch what happens.
The light box moved forward easily while the heavy box barely moved even with more force.
Exactly. That's Newton's second law of motion. Force equals to mass multiplied by acceleration. The more mass, the less acceleration for the same force.
It's like when I kick a soccer ball and a basketball with the same force. The soccer ball zooms forward faster, but the heavy basketball moves more slowly. Or, when Mama pushes me on a small scooter, it moves quickly, but when she pushes me while I'm sitting in a heavy wagon, it barely moves forward.
Excellent observation, children. You're seeing Newton's second law all around you.
Big brother, whenever I or Mina jump forward, we push backwards on the floor.
Exactly. That's Newton's third. For every action, there's an equal and opposite reaction.
So when we push something forward, we move backward a little?
Exactly. That's how a rocket blasts off. By pushing downward, it moves up.
And when people row a boat with a paddle, they push water backward and the boat moves forward. Also, when a swimmer's hands push water back, their body glides forward, action and reaction again.
Excellent observation, children. The third law is all around us in daily life. Okay, heroes, let's take this quest a bit further. Mass is how much matter something has. It stays the same everywhere, but weight depends on gravity. So your mass is the same on the moon, but your weight drops because gravity is weak here.
Whoa! I'd weigh less on the moon?
Exactly. Also, we have another trickster in motion. Frictional force. It resists movement.
So that's why it's hard to slide a heavy box across the carpet, but it glides easily on a smooth floor?
Exactly, Sorrow. Frictional force depends on texture.
Now it's the time for quiz. Are you ready for a fun quiz to test what you've learned about laws of motion? Let's see if you've got what it takes. It's quiz time! What does Newton's first law say about resting objects? A. They move on their own. B. They stay resting. C. They accelerate. The correct answer is B. They stay resting. Newton's first law, also known as the law of inertia, tells us that objects at rest will remain at rest unless an external force acts on them. Why does the small box move faster than the heavy box with the same force? A. It has less mass. B. It has more mass. C. It's bigger. The correct answer is A. It has less mass. When you apply the same force, the box with less mass accelerates more, because Newton's second law says acceleration equals force divided by mass. What's Newton's third law about action and reaction? A. There's an equal, opposite reaction. B. Action is greater. C. Reaction comes first. The correct answer is A. There's an equal, opposite reaction. For every action, there is an equal and opposite reaction. Push on the ground, and it pushes right back at you. Why do heavy boxes slide differently on carpet and smooth floors? A. Frictional force varies. B. Mass stays the same. C. Action reverses. The correct answer is A. Frictional force varies. Different surfaces have different friction. A carpet offers more resistance than a smooth floor, so the same box moves slower on carpet. Why would you weigh less on the moon than on Earth? A. Your mass drops. B. Frictional force weakens. C. Gravity is weak. The correct answer is C. Gravity is weak. Weight is the pull of gravity on your mass. The moon has much weaker gravity than Earth, so you'd weigh less there. That's all for today. Next time, we'll find out what happens when different forces act on objects. Get ready to explore the effects of forces in action. Don't miss out on more free, interactive lessons. Hit subscribe and join us on the journey to education without boundaries.